Number 8. Let's go through and see what we've got here. We have a collision. So right off the bat, hopefully that reminds you, conservation of momentum is how we worked with collisions. Okay, we have a 2 kilogram object, a 3 kilogram object with the initial velocity. Okay, 2 kilogram object at rest. Sorry about that. After the collision, the 3 kilogram object has a velocity of 1 meter per second. Determine the coefficient of restitution. Okay, so we're only given information about one velocity, so this is a one-dimensional collision. Direct. Okay. And so let's draw a before and an after. So we have our 3 kilogram object moving at 4 meters per second, and it's going to collide with our 2 kilogram object. It's initially at rest. Okay, so that's before. So I think afterwards you can see that the red object is probably going to have some velocity. I'll call that v2 prime. Okay, and we're not quite sure what the happens to this one, but actually we do. It says after the collision the 3 kilogram object has a velocity of 1 meter per second. So it's still going positive to the right. So we'll use positive to the right. Okay. The other thing we want to determine really is the coefficient of restitution. So let's go ahead and write that equation. That's the let's see, the negative of the relative velocity after. So v, I'm going to use, I'll be consistent here. I'll just write v2 prime minus v3 prime over v2 before the collision minus v3. Alright, so my unknowns are the coefficient of restitution and this v2 prime. So let's use conservation of momentum. It says the mass of 2, velocity of 2, plus a mass of 3, velocity of 3. The momentum before the collision, linear momentum, is equal to the momentum after the collision. No external forces. Alright, so mass of 2 was 2, and it was at rest. Mass of 3 was 3, and it was a positive 4. Okay, 2 v2 prime, and 3, and we're told that's 1. Okay, so it looks like v2 prime, if I solve this, is going to be 12 minus 3 is 9 divided by 2, 4.5 meters per second. The lighter one takes off at 4.5 meters per second to the right, and then we can plug in our E equation. So we'll have E v2 prime is 4.5 to the right, v3 is 1, v3 prime over 0, so there's 0, minus a positive 4. Alright, so it looks like those negatives will cancel, so I'll have 3.5 over 4. I don't know what that is in my head. 0.875. E is unitless. It's a ratio of velocity over velocity. So no units. 0.875.